compound. So now we have to introduce a term called polyatomic ions. And polyatomic ions, when we name them, we have to use the metal name plus the polyatomic anion name. These polyatomic ions are found in tables 2.4 and 2.5 and in the back flap of your textbook, and I'm going to put a star next to this and say you must memorize these. They will come up throughout the entire textbook, and again, we need to know how to communicate these with chemists. So if we look at a few examples of these involving polyatomic ions, for example, if we have strontium chromate, strontium is in group 2A, so it's going to have a +2 charge. The chromate is CrO4 2-. Again, that's one of the ones that you're going to have to memorize. So we have SrCrO4. That's going to be the chemical formula for strontium chromate. If we have potassium nitrate, nitrate is NO3 with a -1 charge. Potassium's in group 1A, so it's going to have a +1 charge. So that formula is KNO3. If we flip it around and the example we're given is AlPO4, we first list the metal cation, which is aluminum, and PO4 is going to be phosphate. PO4 has a 3- charge, aluminum has a +3 charge, so there's going to be a 1-to-1 ratio between aluminum 3+ cations and PO4 3- anions. The next one we're given would be FeClO4 2. So in this case, we have iron, and we're going to have perchlorate, which is ClO4. Perchlorate has a -1 charge. If we have two of them, that means the iron has to have a +2 charge. And remember, iron is a transition metal, so we need to list its charge in parentheses. So the correct name for this first compound would be iron 2 perchlorate. Now, the thing that kind of stinks about these polyatomic ions is that there's a lot to memorize. So as a helpful hint, I'll kind of put together here some hints for polyatomic ions. And the main hint is to first memorize all of the polyatomic ions that end in 8 and then go from there. So, for example, if we look at all the polyatomic ions with the 8 suffix, we have NO3, and it has a -1 charge. Then we have SO4, which has a 2- charge. So we have nitrate, sulfate. There's also phosphate, which is PO4 with a 3- charge. And then chlorate, which is ClO3 with a -1 charge. I'm going to put a box around here and tell you that you need to memorize all of these particular anions and their charges. Nitrate -1, sulfate -2, phosphate minus 3, chlorate minus 1. Memorize both the number of the oxygens and the charges. From there, you can go on and derive a lot of the other polyatomic anions by knowing a few tips. The first tip is when you go from an 8 to an ite, you simply keep the same charge but reduce the number of oxygens. So here you go from NO3 minus to NO2 minus for nitrite. Sulfite is going to be SO3 2 minus. Phosphite is going to be PO3 3 minus. And chlorite is going to be ClO2 minus. So when you go from an 8 to an ite, you keep the same charge, you just remove one oxygen. Some of these complexes have something called a hypo, and then the parent name, and then ite. This happens for the halogens, which chlorine happens to be one of. When you go from an ite, in this case a chlorite, to a hypochlorite, we remove one more oxygen. So that gives us ClO, again with a minus charge. In addition, you can go from the chlorate to something called perchlorate by adding another oxygen. So here you have ClO4 minus, which is perchlorate. So going from the bottom to the top, starting with perchlorate, then which is ClO4 minus, then chlorate, which is ClO3 minus, then chlorite, which is ClO2 minus, then hypochlorite, which is ClO minus. This right-hand side of the table here works for any halogen. Halogens we typically abbreviate with an X. So if we have XON with a -1 charge, this is going to work for any halogen. So it works for fluorine, chlorine, bromine, and iodine. So iodate would be IO3 minus. Iodite would be IO2 minus. Hypoiodite would be IO minus, and periodate would be IO4 minus. So this table right here can give you a little bit of a hint to see how well you can name each of these polyatomic anions. And again, it's going to take a little bit of memorization, but if you memorize all the 8s, this table then can help simplify a lot of things. So next, we need to talk about the nomenclature involving molecular compounds. For molecular compounds, if two nonmetals form a compound, a prefix is used to indicate the atoms in the formula. And again, these rules are different than the ionic compounds, so you must be able to identify an ionic compound from a molecular compound. The prefixes that we're going to use, if there's one of something, it's mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. So these are the prefixes that we're going to use for a molecular compound. So let's go with some examples. The first example would be N2O. N2O is going to be, we have two nitrogens, so we need a di. So it's going to be dinitrogen monoxide because we only have one oxygen. If we look at SO3, we would say that there's one sulfur, so that would be monosulfur trioxide because there's three oxygens. Now this comes to where we can try to simplify things a little bit. So to simplify things, if we start a complex with something with one, in this case sulfur, we drop the mono prefix. So we just refer to this as sulfur trioxide. Same thing happens if we have IF5. This is going to be iodine pentafluoride. Okay, we can do the same thing by going from the written formula in words to the chemical formula. So if we have dinitrogen tetroxide, dinitrogen, there's going to be two of them, so it's going to be N2 tetroxide O4. If we have sulfur hexafluoride, we can say that there's going to be one sulfur. Again, we drop the mono prefix, and it's hexafluoride, so it's going to be F6. So the chemical formula here is going to be SF6.